This video, I'm going to start looking a little bit on the idea of magnetism being caused by the flow of current. Remember back to one of our earlier videos, we talked about the idea and the concept that magnetism is caused by the spinning effect of an electron. Well, the same is true when we have a current flowing in through a wire. First thing we're going to do is we're just going to introduce the concept of wire and current. Just remember back when we're going to talk about the idea of conventional current and of electron flow as being in opposites in a different video. However, in this one I want you to just consider the idea of conventional current. So if I have got two wires here and I've cut them straight through, so these are wires that I could draw something like this, and we're looking at it from the end like so. Then imagine yourself looking at it in the same way that we would do an arrow in a darts game or a dart. Then the direction like so, this is when the current coming towards us. So in this it is current out of paper. In this case it's the current coming out of the screen towards you. And if you look at the back of a dart, you'd see the feathers, and it would look like this. And this is when the current is going into paper. Now, if we have a little experiment that we could do like this, and we have a perspex sheet of a certain thickness, and we cut a hole in the middle of it, something like this, and through that hole we pass a wire straight through the hole, and the wire comes out at the bottom like so. And we're going to pass a current through this wire. Just going to try and give us a sense of perspective here. If we're going to pass through a current through this, so if we have a plus here and minus here, the conventional current is that it goes from plus to minus, so it's going to go upwards. Now, until we switch on the current, of course, there is no magnetic field in place, but as soon as we switch it on, what we find is if we pour some iron filings, it will create concentric circles around the center of this, like so. And if we put plotting compasses to it, so I have a little plotting compass here, you'll see it's going to point in a direction as well. So this is a magnetic field going around in a circle. Now if we look at this from above, we will see, because the current's coming out of it, I'm going to put a dot in the middle of it, and we're going to have our magnetic field lines going around like so. And an easy way of remembering this is what's called the right hand rule, right hand thumb rule. And if we take a thumb and we imagine this to be holding our wire, like so, then if I draw the wire going through this hand, like so, and the current's going up in the direction the thumb is pointing, of the current, of course, is the conventional current, what we'll find is that our fingers are clasping the wire in the same direction that the magnetic field would be going. And this is called the right thumb rule. And it's an easy way of imagining or seeing the direction of a magnetic field around a wire in which there is current flowing.